All right, Desert Ridge Academy 6th graders, it is time to do our notes on function tables. So to start, our essential question: how can a function table help you find the inputs and the outputs? All right, a function rule like y is equal to x plus 7 describes a relationship between each input and its one and only output. You can organize the input-output values and function rule in a function table. All right, you would see these in elementary school where you had something like the following, where you had, like, let's say I put a number in a box like 7, I put it into my function, so that would have been the input, and out would have popped, so you wouldn't know what was happening, but you know out popped 10. And then let's say I put into the same function 8, so that would have been my input, put it through the function, and out popped 11. You're looking for, what's happening? At this point, I know some of you are getting it. You're like, if I put in 9 into this function, out popped, I'm expecting 12, because I see all we're doing is adding 3 each time. Indeed, this is what you would have seen in elementary school. You were working with functions. We have exactly one output for every input. Well, that's what we're going to do here. We have a function table to help us organize our information. So, my x is always my independent number because that's any number I can pick. The output is y, which is the dependent number, because it really depends on whatever number I put in to my function. That's going to determine what my output is. All right, so here we have some values for our function, which is x plus 7. So this is basically the rule that's going to give me the y. So I have 10. I'm going to add 7 to it, so I put in 10, added 7, out pops 17. So I would put in 12, add 7, out pops 19. And then if I put in 14 into my function, it's adding 7 to that number, so out would pop 21. That's the basics of what we're going to build on. So let's do it again. This time our rule is 3x minus 1. So we're going to take our input, multiply by 3, then subtract 1. So I'm going to write kind of tiny here so we can fit all of it, and look at that, zoomed in even better. All right, so we have 5 is my input, so it's 3 times 5 minus 1. Well, 3 times 5 I know is 15. 15 minus 1, output would have been 14. Put it in my next input. So it's 3 times 6 minus 1. So 3 times 6, 18 minus 1, output would have been 17. And then if I put in 7, so 3 times 7 minus 1, 3 times 7, 21, minus 1, the output would have been 20. Pretty simple. You just follow the rule to get your inputs and your outputs. Well, to get your outputs based on what your inputs are. And now to our all-important word problem. Brian hikes 12 miles per hour. This 12 miles per hour we know is a unit rate, which is also going to function as our rule. Next, the function rule that represents this situation would be y is equal to 12 times x, or 12x, where x is the number of hours, that's important to connect, and y is the total miles. All right, make a table. So that's our first thing to do. Make a table to find out how far he has gone in the all-important 1, 2, 3, and 4 hours. And then our next thing to do would be to graph. So we have a lot going on in this problem. We're going to take it step by step so that we don't miss a part. We know x represents hours, and it told us we have to account for 1, 2, 3, and 4 hours. So those are the numbers we're going to use. Next, we're going to determine our outputs, our y's. So we take our rule. 12 times x is going to give us y, and so we take 12, multiply it by 1. So after 1 hour, he would have traveled, well, that's supposed to be miles. he would have traveled 12 miles. Next, after 2 hours, so it'd be 12 times 2, 24 miles, then 12 times 3 for 36 miles, and 12 times 4. So we used our rule to get our output, 48 miles. Nice job, Brian. Now, in order to graph, we're going to need something called ordered pairs. And those come in the form of our x and then our y. So here we can see our x, our independent variables. It was 1, and when we put in 1, out popped 12 for our y, so we have 1, 12. Next we have 2, that was our x, and at 2 it was 24 for y. Then we can continue 3, when we put in 3, out popped our y of 36, and then when we put in 4, out popped the y of 48. So now we have the ordered pairs necessary to graph. When we're graphing, we want to make sure to graph, we want to make sure that we, one, title our graph. We want the reader to know exactly what what is being pictured, shown through a picture here. So we want to make sure we title it. Next, we're going to make sure to label our x and y axis. And then, of course, you're going to need to decide on a scale. Because we wanted to show how Brian's bike ride went, so the distance he traveled. So for our x-axis, we know that is our axis that goes along the horizon, tells us which way to go side to side. And we have enough space, so let's make every 2 boxes count for an hour. So this will be 1, 2, zoom in slightly. Okay, 1, 2, 3, 4. We can fit 6 hours, and this is the number of hours. So we've labeled our x-axis. Now we're going to do the same thing with our y. This is going to represent, I'm turning the page for a moment, number of miles, so the distance he's traveled. And I'm going to let every 2 boxes here represent 12 miles. So 12, 24, 36, 48, 60, moving all the way up, 72, 84, and then we end up with 96. Perfect. Now we know this point here would be our origin, 0, 0. That's always good to know. That's where the x and y axis come together. And now all we have to do is plot our points. We crawl before we can stand. So we crawl before we can walk. So we have 1, 12. So we go over to 1, up to 12, put in our point, that's 1, 12. Next order pair was at 2, 24. Then we had 3, 36. And then 4, 48. Make sure you have your parentheses around them. We can see our lovely points. And we are done with the first part of our function table lesson. See you in class.